Hello everyone, welcome to my channel, the Code Crunch, and welcome to a new video that we are going to learn about different topics again, and which is about the basics of the program coding languages. Previously, we have learned about the difference between the procedure-oriented program as well as object-oriented program, and we also learned the different steps that we follow to write a program, which is an efficient program. So here today also we are with some of the topics, that is the designing tools, which is the second step as I have said before, and the first one is the algorithm, the second one is flowchart, third one is pseudocodes. All right, we'll go with the algorithm. As I have said it previously, algorithm is nothing but the step-by-step procedural or set of rules used to solve a specific problem or perform a task. It consists of sequence of well-defined functions, instructions that takes inputs, process it, and produce an output. As I said, because it is nothing but the normal list that we follow. For example, I have given here the recipe of the cooking dishes, or cooking a dish, or find a word in a dictionary. That we have certain rules that we follow by finding a word in a dictionary. So this is how the algorithm works. So we'll go for next. We have some of the rules that we can say is that in order to qualify as an algorithm, that means that if we are writing an algorithm, if that should be understood or that should be good enough. So that is nothing but in order to qualify an algorithm, a sequence of instructions must process the following characteristics. So let's go with this. First it should be precise. Second, it should be unambiguous. Third one is not even a single instruction must be repeated infinitely. And the fourth one is after the algorithm gets terminated, the desired result must be obtained. So we'll go with the first one. First one, precise. Precise means it should be accurate. Okay. For example, sum of two numbers. In sum of two numbers, we are clear with we are adding two numbers. Okay. Second one is unambiguous. Unambiguous is nothing but clear. For example, sum of two numbers. Here we are clear with we are adding two numbers and we can get our output. Okay, so this is what we are clear about the whatever the program we are writing. Third one is not even a single instruction must be repeated infinitely. For example, we have some of the other programs where uh, we use for loops, while loops. They are the loops where we repeat our programs. We use certain functions, certain statement, or what we can say conditional statement, or we can say flow control. Here it's that not even a single instruction must be. For example, I gave a sum of two numbers. In sum of two numbers, nothing is repeating again and again. It is one. It is first we'll take the input, we'll process it, and after getting the result, we will print on the screen. So this is what happens. The fourth one is after the algorithm gets terminated, the desired result must be obtained. It is nothing but that whatever the program we are running or the algorithm that we write, we must get the result that we want as sum of two, adding of two numbers. That, for example, 3 plus 5, we must get 8 when we write a program. So this is what it is. We'll go with our next thing, that is types of algorithm. There are three types of algorithms, that is sequence algorithm, decision algorithm, and repetition. Sequence is nothing but the linear or the step by step or a straight, like each step of algorithm is executed in specific order. Yes, like each step by step everything is done. So here I have given the example of sum of two numbers. Step one is input of the first number, second one is input of the second number as b. First is a, second is b. Third is sum set sum is equals to, we are setting a variable. Sum is nothing but variable here in the program, and a plus b is the procedure or the calculation that we have to do. And what we do is, next we print the sum and we end. So this is how it works. Second one is decision algorithm. This is where we make decisions, okay, whether a is greater than b, or 4 is greater than 5, or 4 is smaller than 5. This is how we make decisions. There is just one output, true or false, if yes or no. So here what it is, it is used to when outcome of the process depends on source condition. Conditional statements are used like if, else, elif, etc. So here we use conditional statements. We have different types of conditional statements like if, else, if, elif, or nested if. There are different kinds of condition statements. Here we have, I have taken the example of equality of two numbers, and this is how we write the algorithm. First one is start, second one is input first number of x, then input second number of y, then we have if a is equal to b, then print. Here we are writing the condition, that is a is equal to b, if a is equal to b or not. This is what we are going to say. And then after we write else, then we write print equal or not. If it is true, it will print equal. If it is false, it will print not equal. And step 5 is we are ending with our program again. So third one is repetition. Repetition is nothing but repeating again and again. For example, a loop. A loop follows again and in a coding language we use loops. That is a statement or condition. So this is the third one, that is repetition involves execution of one or more steps of a number of times. Loops are used like while, do, while, and for loop, etc. So here nothing but it is the repetition of the same condition, or the repetition of the whatever the condition we go with the example, that is print the first and natural numbers. And natural, where it starts from, let's take from, it starts from 0, but it actually starts from 1, but we consider here as start with 0. Okay, so first is start, second one is initialize. Set I is equal to 0 and n is equal to 1. Initialize is nothing but we are so here we go with the second type, that is flow chart. Flow chart is nothing but the symbolic representation. So it is nothing but the symbolic representation of algorithm. That is another, we use different steps to for writing different. For example, we have seen previously 3 programs or 3 algorithms. In that, first step was start, second step was input, third step was processing, fourth step was printing, and this fifth step was printing, and sixth step was ending the program. So same as it is, we'll see the different shapes for that. And it consists of sequence of instructions that are carried out in an algorithm. The different instructions, that whatever we write in an algorithm, the same thing is converted into flowchart. The first step is starting, right? So we use some shape and we like start. We'll write an arrow mark. So first we write here start, then we give arrow mark, then we write our condition, again we write put arrow mark, and we take our inputs, and again after this we follow whatever the processing should be done, like this. Again we write the next, again after when everything is get printed, for printing purpose we use this one. Again after this we use oval shape for ending. So this is how it works. It consists of sequence of instructions that are carried out in algorithm. All the steps are drawn in the form of different shapes of boxes, circles, and connecting. As just now I showed you before, it is how we use. Let me show you next. Yes, here are different shapes that we use. Square. So I mean to say oval, or it is not a square. We can see here. It is not a square. It is something like this. We are writing boxes, again we are bending here at the corners, something like this. Okay, so this is for starting and ending, when we start a program or when we end them, as well as showing the directions, like which way the our flow chart is flowing. And the second one is the processing. I think I've showed you wrong. So square is rectangle is for this, for processing purpose. And next one is uh, parallelogram. huh? It is used for input or output operations. Next is rhombus, that is for conditional decision making, as we used for loop or while loop just now we read in the previous programs. Circle is for connector. It is nothing but it connects between two different programs or two different parts of the program. This is for again conditional shape. See here, in rhombus we use only if, else, elif, nested if, and but in this shape we use while, do while, for loop, something like that. And this is, I don't know what the shape it is, but it is with square with two parallel lines between them. It is predefined computation process. We use it rarely. We'll see in the next. So this is our example of flowchart. All right, so here we are using oval shape for start, parallelogram for input and all, and here we are using for output as well, the parallelograms. This is oval shape. These are the printing statement or input or output one. Next we are using rhombus shape. Rhombus is that we, as I said, we use for if, else, else if, else if is nothing but elif. Next we use nested if, and this is for if we are reading ABC, we take input as ABC, we say if A is greater than B. If A is greater than B, then check for next condition. If A is greater than C, if it is true, print A. Again, if it is no, the condition here, if A is greater than C, if condition is no, it will print B. And if A is not greater than B, then it will print, it will go for next condition. Here we will, while writing the program, we use elif, that is nothing but else if, right? So here how it's work. So we'll check for this condition. If this is false, again if it is true, it will print C, or if it is false, it will print B, and we are going to stop our program, or execution stops here. This is our flowchart. So here we go with our third type, that is pseudocode. Pseudocode is nothing but, as I said you before in my previous video, that the Sudoku is nothing but the false code. We write the program exactly, but we use a little English words in order to explain the uses. I mean to say, it is not exactly the program which can be executed. So this is what here is. It is a way of writing algorithm using a mix of plain languages and programming like structure without following the strict syntax of a specific programming language. It helps programmer to plan and understand the logic before translating it into actual code. So let's go with the, then you can understand better if we go with the example first. If finding a even or odd, first step is start. We use oval shape for starting, input parallelogram, processing. It is if is given, uh, we will use rhombus. After that, ending is this, and in between printing purpose we also use rhombus. Yes, so here first step is starting, as it is almost similar to algorithm. First step is start as usual, in taking the input number as usual. Third one is we are writing here the condition there. If we don't even write the condition, and only if we write in simple English, then it is called an algorithm. But in this sort of code, we must mention what logic we are using. Here we are using n modulus equal to 0. And modulus is nothing but whether the given number is exactly getting divided to 0 and the remainder is equal to 0 or not. Modulus is used for seeing the number of an divided number. For example, we are given with 3 is divided by 2. Then if whatever the remainder what we'll get, we get remainder is equals to 1. If 1 is equal to 0 or not, it will check for it. If it is false, it will print odd number. If it is true, it will print even. For example, 4 divided by 2, here the remainder will be 0, which is almost equal to 0, which is exactly equal to 0, not almost, it is exactly equal to 0. So it will print here even and it will end. It depends on what the number we have given here for the n number. Okay, so we'll go with our next. So see you guys in our next video, or will coming soon with our next new videos. So here, this is what we have topics, and we have learned the different types of algorithm as well. And the second one is the flowchart, that I have showed you the different shapes that we use. And the third is the pseudocode that we use. It is something like exactly algorithm, but it is not exactly like algorithm. Here we use condition, and in the algorithm, if we don't even mention the condition, it will be called as the condition. Okay, so hope you guys have liked this video, or you have understood whatever the doubts you had regarding these topics. So hope we all guys will do for the next. Will wait. If you like, please like, share, comment, and subscribe as well. So we'll meet our next video. Till then, bye bye, take care. Please don't even forget to subscribe, like, share, and comment. Thank you.